Good morning, good afternoon, and good evening, wherever you are in the world today. My name is Ed Hodson, and I'm the chair of the IOSH Railway Group. And on behalf of the committee, I'd like to welcome you to our international virtual conference today. This morning, we have a truly international perspective where I'm privileged to welcome Professor Vincent Ho and Alex Lau from Hong Kong, but Vincent is joining us today from Los Angeles. So we really do have an international conference. And we'll be looking at how intelligent safety is used in the Hong Kong Mass Transit Railway for the benefit of passenger and staff safety. First of all, I'd like you to hear about Vincent Ho. Vincent Ho is a career management safety professional with 37 years of experience in transportation, nuclear, aerospace and defense industries. Vincent was also the 52nd president of IOSH. He's a support advocate and advisor, and he trains in health and safety professionals in all organizations around the world. And Vincent received his PhD and MBA from the University of Los Angeles, where he's working actually now, and joins us this morning at 1 o'clock or 2 o'clock in the morning. He actively promotes the management enhancing safety. He's founding chairman of the Hong Kong Association of Risk Management and Safety. And what Vincent doesn't know about health and safety, then I don't know either. He really is the fountain of all knowledge in health and safety around the world. Joining Vincent is Alex Lau. Alex is the Principal Health, Safety and Quality Manager at the MTR, Mass Transit Railway in Hong Kong. He's a chartered engineer with over 20 years experience in rail safety, and this is in safety management systems, engineering, and the competency systems for safety critical operations. And Alex is also our first international member of the IOSH Railway Group. So it gives me great pleasure to start by introducing Alex to start the presentation. Thank you, Alex.
Thank you, Edward. Thanks for the good word and introduction. So, and I'm also very happy to have Vincent with me because, as you said, anything I don't know, then I'll ask Vincent to supplement. Anyway, now, without further ado, I'll try to bring up my slides first and see if everyone can see this. Right. So do you see the slides now?
Yes, yes.
Okay, good. So good morning, good afternoon, whatever, good day for everyone. Thank you for joining this discussion. Today, I'm going to talk about quite an interesting topic where in our cases in Hong Kong MTR, we call it intelligent safety. But actually what we're talking about is the application of technology and innovation into making people or your passenger more safe. So, hold on, how to do this? Right, now, the reason we want to talk about this or more about this being discussed nowadays is because the technology are now emerging more readily available and they are much cheaper to use. And you also find that they are now becoming more and more powerful. For example, robotics now with this COVID-19, you see more robotics are used either in cleaning or delivering your meal to your table, etc. And you find IoTs, cloud technology, AI, VR, gadgets everywhere, and they are really a lot of people making use of all these new ideas to improve the quality of life and also improve safety in particular. Well, I show a small map here that showing you how how my company is now actually trying to make use of all these technologies to do what we call a digital transformation. What we are doing now is to try to incorporate technology everywhere, from maintenance, from making people your trains infrastructure safer, and also we have an idea that we have to invest in making us improving safety. So before talking about what we're what we're doing now, maybe we better go back to the basics of safety, that we are talking about hierarchy of controls. And so whenever we bring in technology and innovation, what we are thinking about is whether we can apply these ideas to help us to eliminate, substitute, or better control safety. For example, whether we can introduce technologies to help us to predict and prevent failures, or eliminating some high-risk jobs, labor-intensive jobs, or give workers or passengers earlier warning and alarms about anything abnormal is going to happen. And we can also use technology to give us more accurate analysis so that we can do better decisions. And last but not least, technologies can also help to protecting people from harm. And there are a lot of smart PPEs nowadays available to help to prevent workers. So in the coming 10 minutes or so, I'll briefly give some examples in what we are looking into or what we are using now in Mass Transit Railway Hong Kong in what we call applying the concept of intelligent safety into the railway. And thereafter, we talk something about the implications of using this transformation, whether we are going to solve all the safety problems altogether, or we are going to introduce some new challenges to safety professionals like you and me. Now, talking about prediction and prevention, one of the applications is to use video analytics to monitor the condition of our component. For example, here we use video analytics to monitor the condition of a pantograph. Well, someone may know that this technology has been available 10 years ago. Actually, more than 10 years ago, we had one in our depot, and we used a very first generation digital cameras to take pictures of every train that passed through that depot and then do some analysis. But that is terrible. It's never accurate, and the image, the quality of image, the quality of the data and analysis are very poor. But nowadays, with all this 3D processing, AI, and very high resolution cameras, we can accurately predict the wear of each very tiny component, and actually comparing the wear of a particular train one by one. And we have this both installed on trackside, and also we can install some on top of the train and do another way of monitoring of the condition of the overhead line system. So this gives us far more accurate, not just to preventing failure, but also reducing the time that our colleagues need to go to the roof of a train to fix all this pantograph problem or doing inspections. It automates a lot of inspections. So if we can do it in the pantograph, then we also can do it on the track. And so a lot of sensors are now installed in the train. It is just on our daily running trains, our EMUs that run along the railway. And they have sensors that can tracking the vibration, the gauge, and all the condition of the fastening, etc. on the rail, and give real-time data back to our data server. And it gives us all the trend monitoring, particular hotspots, etc. So our track maintenance colleagues can actually do more timely inspection and condition monitoring of the situation. Some of you might have just read a report from our AIB about a freight train derailment in UK. And if you read this report, you can spot that one concern our AIB is talking about in that derailment incident is about the capability of measuring the dynamic performance of a track. So traditionally, your patrolman walk along the track, he only sees static situation. And even if he put a gauge there to measure, it's all static. Well, some of the experienced patrolmen can stand next to the track, listen, observe train passing by, and tell from their experience whether the track condition is good or bad. But of course, in Hong Kong, we no longer do that because we do not allow daytime track access. So this is a different thing. But with all these technologies, we can reduce the amount of time our patrolmen spend on the track, and they are actually asked to go to areas where this track monitoring equipment tell us where the problem might be, and then they do intervention. And I can tell you that we have successful cases where this system capture abnormal track gauges or abnormal vibration, and where our staff can intervene immediately. And you also probably notice that this technology, we do it jointly with another university in Australia, and the university also get real-time data, and so they can help us to improve the model as well. Now, on top of preventing and detecting, as I said, it can actually help you to take what we talk about as intelligent safety is also automating jobs. Well, a lot of labor-intensive, high-risk job can be automated. We now have machines for doing cleaning jobs, machines for moving heavy-weighted components, and we can also use robots to help us to do the underframe inspection of trains coming into the depot. And the beauty of AI inspection is actually that they will not miss anything, because whatever you program them to look at, they will give you a measurement, a picture, or a analysis of the condition of the component. Now, for passenger safety, here is an example of where we apply to light rail. Light rail is one of the most problematic challenges actually to MTR Hong Kong, because it is the only system that we operate in Hong Kong that do not have a fully enclosed system. It shares a portion of the track with road vehicles, and also we do not have platform screen doors, etc. So it has a lot of interfaces with road traffic and a lot of interfaces with pedestrians. Now, what we are now applying is some kind of video analytic in the junction, where we can early detect any vehicle trespassing into the junction, and this can send a signal to the approaching train to warn the driver that some road vehicle is going to trespass, and they can take intervention earlier. And similarly, we can send signals from the train to a pedestrian crossing. You see this small picture here that there is a bollard. This bollard gets a flashing light. And so when the train is approaching, it flashes and gives audio and visual warning to the pedestrian that a train is coming. And so with this is a very simple technology. And the problem is now we are fine-tuning the AI part about giving accurate prediction about whether a road vehicle can enter in a junction wrongly, or it is not. The accuracy still need to be fine-tuned. That is the only part we're doing now. Another example on helping passengers is that the top incident in MTR is escalator incident. A lot of passengers using escalators and also carry bicycles, carry baby pams, luggages on them, and which create a lot of hazardous situation. In this trial, we are putting a LiDAR system in front of the entry gate. And the LiDAR system can learn and detect whether the passenger is carrying a bulky object and is about to use the escalator as well. You can see it can predict the fault of the passenger as well. So when the LiDAR system detects such a behavior, you see that I showed two pictures on the floor that it will project a projector or an image on the floor, encouraging the passenger to use the lift instead of an escalator. So the passenger will get a prompt about, okay, you are now carrying a bicycle, so please do not use the escalator. Please use and this is only we only tried this early this year in one station, and we are now trying to monitor whether this can help changing the behavior of the passengers. If only a sort of video prompt cannot change the behavior. We can always do a stronger intervention. This system can actually send messages to our station staff, and they can intervene earlier. And on top of detecting people carrying bulky luggage, the AI can also predict whether a passenger is actually drinking too much. And then we can also intervene them, because we sometimes have drunken people using escalator and fall there, and which is a very dangerous situation. And so it is a very promising technology, actually. And also the use of LiDAR help to sort of prevent people questioning about data privacy. Because nowadays, a lot of people are worried about use of CCTV, where you can capture people's face, you do video and edit, and then they're afraid of all sorts of privacy intrusion. But use of LiDAR eliminate totally this. And also because LiDAR is a sort of using a beam to actually hit the object, it is not like video analytic that it depends on a lot of algorithm to analyze a two-dimension picture. So it is quite promising technology. And we are also using this in some of our level crossing as well. Now, this is one of a very innovative idea that is I would want to call it a low-cost ATP for a light rail system. What we did in light rail, because our light rail system was built many years ago, it is a line of sight driving. Drivers have to observe signals, and all kinds of problems like signal pass a danger, overspeed, etc., can happen. And so, with a view to reduce these occurrences, what we do is we put GPS and RFID into the trackside and on the vehicle. And with GPS and RFID both working together, we can accurately position the train location and the direction and the speed, etc. And therefore, this gives us capability of supervising the speed, whether they are going to the right turnout or not. The platform, whether the train is stopping at the door can open or not in the right platform. And we can monitor the performance of individual drivers, and we can also prevent what we call a conflicting movement, where in some junctions of this light rail system is totally not interlocked, and you can have a possibility of vehicle collision in these junctions. So we are now in the second phase of the system already, and it is a CO2 certified system. And the system now is only giving alert to driver. So if they overspeed, or if they are about to pass a signal at danger, the system will give warning, audio and visual warning, and the driver can stop it according to the warning. Now we're moving into the phase 3, where we will actually give intervention to the braking system. Now this is really a challenging task for us, because doing that, we have to be very sure that the detection and the logic is properly correct. Otherwise, it will stop the light rail movement all the time. So wait and see. But now we are already on background test, and seemingly everything goes very good. Well, another example about safer working, and I understand that yesterday you're talking about an incident of people working on trackside, and we also have this challenge of people working in what we call engineering procession, or in UK I think you call it TV procession, something like that. And so the intelligent safety, including we are trying to start from planning how we allocate the processions, resources, people together using an AI technology, so that to come up with a best combination of people doing work at where and how to move the trains in out, etc. And then within the procession itself, we're now working on automating the boundary warning signs, what we call a red flashing light, or you call a stopwatch sort of thing. And all this smart idea come into play with the whether the padlock of the particular trackside access, if you do not get the approval from the OCC according to the planning, you can't open the padlock because it is a smart lock. And for isolation of the overhead line. We also have looking into remote earthing, so we don't need to have people intervention into switching off, isolating and putting earthing what there. It's all automated. And last but not least, there's what we call a safe track app. So this app will enable everyone going into the track area to ensure that they go to the correct website and they get proper authorization, and we can track people who had entered the site, number of people, where they are working, where there are other trains moving nearby, and give them warning and making sure that everyone leaves the track before we resume services on that particular line for closure. We are doing this now bit by bit, and about the remote earthing and some of the automation are still in the development stage, but the refreshing line, the safe track apps, etc., are all in place. And we really enjoy not just a safer working environment, but also enable us to have a longer working window within this procession hours. So it actually helps productivity as well. Well, if you remember this triangle of the hierarchical control, we always look for also the last line of defense about PPE. And this is another example, not an MTRO introduction, but we are trying on this technology as well. It's some sort of smart PPE. This is a helmet, where you have IoTs there, and it can sense your worker's heart rate, body temperature, whether they are falling or whether they are stand still so for a long time without any movement. So it gives warning to the supervisor that the worker might be in trouble. And one idea of this smart helmet is that it can also have an interface with other moving machines nearby. So this can help eliminating the chance of machine hitting people. Well, Vincent, am I over time? I want to give it one slide for earlier. Yeah, because well, I've gone through a lot of examples, and I can run another 10 of them as well. But I would like to stop here to do a little refresh that. Well, if you think about whether this new technology can really remove all kinds of challenges like human error that we are facing. Well, I quote Sidney Dekker here that he said that new technology does not remove human error, it just changes it. So what we often think is that with some technology, we can help improving or monitoring the work. But if you really think about it, it's just changed the mode of working, and errors still exist. And here I just while I'm preparing the slides, I read the RSSB research, and also I found the quote is interesting example that RSSB has conducted some tests on this smartwatch that's supposed to give you assurance about fatigue risk, but also but what they conclude is that it can also give false assurance as well. So I'm not talking about this is not good, it is terrifically good, and it wakes me up every day. So now, Vincent, I know you can't wait to jump in. So what's your view? Are we actually helping improving safety, or we're bringing in new challenges? What are your advices?
I'm learning from you all the time. I think people keep thinking new technology will solve all problems. And if you look back in the past few years, when virtual reality training comes up, almost everyone will have projects talking about virtual reality. I think we'll some feedback here. So let's move. I'm trying to control the slide. This page is supposed to have engagement with all the participants to talk about, will these technology actually become the dominant source of error and hazards and risk? When we delegate our task, safety critical tasks, to the machine, and is that a good time to do that? Do we have other supporting elements such as training, the learning of the old technology, and all this stuff? So we have a list. Alex and I work on a list of the hazards that we can think of. We do a little hazard internationally in Hong Kong and LA that we think there are several areas that human may become actually the problem. And when we introduce technology, that although we all try to embrace new technology, we must make sure that we are handling all the risk and hazards well. For example, even in the past few years, we have seen several accidents coming out from switching technologies. One of them is mode error. People may expect the computer to do something, but actually the computer is doing something else, or the system is doing something else. And looking back a few years ago, we have an accident in one of the cities that we operate in. I said we is a company I used to work for. And somehow the contractor put the system on test mode and forgot to change it back to actual mode. And the operator start running the actual operation of the metro system. And at 7:25 peak hour, then the test mode failed. And it ended up crashing the whole line, and with 1 million people jamming the city streets. So Alex, do you have another example that we can show in this area?
Yes, I think when you talk about this mode error, clearly that the test mode that you mentioned is a classic, and also what I can think about is nowadays a lot of new systems are built in FAO, what they call a driverless system. Yeah, so you get all the features of the driverless system built into your train, but eventually your regulator do not allow you to run driverless, and you put drivers there. But it's because of this particular driver and his particular behavior at under certain situation actually bring the train to a completely stopped situation, and it is not uncommon, I would say, in such systems.
We are calling those train ambassadors. Another fatal mode or another interesting point is interface complexities. Once we jam all this information, and sometimes when you look at the display, it's very difficult to find what you want to see. So even though we have training after training, and sometimes even your smartwatch, you look at it and there's just so much information over there, and you pretty much have to kick out some of the not so used information. But then when you use it, you don't know where to find it. Other thing is, if we use AI and we have to fill out computer forms, and if the user doesn't know how to fill the form correctly, then you become GIGO. It's like garbage in, garbage out. So I think so far we use the AI and all these new technology on monitoring and diagnostic and on maintenance is quite good. On FAO, if it's a one-line metro system, then it is also very good. But if it's a mixed line complex network, then we are still trying to hold back and want to see how it goes. Then when you use more new technology, actually the train driver or the captains will have more work to do. And sometimes you become so busy with the computer and other things that it might not be able to handle their work correctly. So we always try to look for any slap and go features, like I can take a picture of my mobile phone or my cell phone, and then the phone itself will quickly monitoring all the required elements and then give the information and fill out the form automatically. That would be our dream. And sometimes even we have this mobile phone reporting system or data logging systems. And some of the projects people may also find it too much work to do. They pretty much want to take a picture and let the picture speak for yourself. So all these may become another round of problems if we don't manage it well. For example, data overload. If we have a lot of information, we end up just bypass it. And just a classic case is when you have too many alarms, you turn them all off. Or you have too many false alarms, then you don't trust the system. You pretty much shut down the systems. I think, Alex, we have several accidents like that before, didn't we? Or not we, but in the world.
Well, when you said we, yeah, I have a little bit surprised, but anyway, yeah, you're right. In particular, alarm overload is a quite typical situation, and I can tell you that not just alarm overload, but also the designer, aware that the alarm can actually have problem. We have a new case where in our signal listening system, it classified alarm into red, yellow, or white alarm, so it as to let you know the seriousness of this alarm. But then when all three alarm comes up, actually they superimpose each other, and then the operator is not know that he has to handle 3 alarms instead of just 1, and therefore we end up in a little disturbance there. That after that we learned, oh, if the alarms are superimposed one another,
and then get pages and pages of alarm. I
Oh, yeah.
once visited a station of not our company, other companies. They have like pages of alarm coming out. So I've asked the operator, how do you know which one is important? He said, well, we end up just throw the pages away. We don't even read them. And if it's important, then we'll smell it. Then they also go to what we call automation surprises, that sometimes the computer system will do things that the user may not be familiar with, or not trained, not remember. And you end up with a very thick user manual, but like most people, we read only a few pages. But usually when you look at a system, you expect it's kind of like touch and go. And if you look back, not the rail company, but maybe the airline companies, one of the key programming error was the 737 MAX, that it is actually doing something that it was designed for, but however, the wrong timing, and the pilot would not be able to taking over. So what would we have in this area in terms of railway automation surprises?
Well, I think it actually tied up with not just an when we call automation surprise, actually is something what we also call it unknown, right? The programmer might not actually know about this, the condition that the technology is going to apply for. One really typical one is, I think you and I use GPS, right? When we try to use a system to detect where our colleagues are working, and the first system we ever try is a GPS. And the surprise is that, the GPS cannot tell actually if someone is working on a viaduct or just drinking a cup of coffee on the roadside, and a lot of stuff suddenly entered into your railway system and give a lot of alarms up. So eventually then we get rid of this idea, and we said we have to put our RFID together with this GPS. But then our RFID also got a problem with when we work in our tunnel, there are a lot of abnormal bounce back of the signals as well. So a lot of fine tuning is needed. Otherwise, you got a lot of surprises.
Yeah, talking about GPS, sometimes if you turn on your Google map and try to go from point A to point B, I've been doing that every day now. I mean, I've been driving 2 hours every day now. And sometimes point the direction, say, I'm going north, but the GPS tells me to go south. Should I believe it? Should I trust it and take it a go? Or should I just go back to my normal route? And that's usually, surprisingly, that most people will just ignore it and go back to whatever they think it should be, rather than follow the Google map. And Google map actually just trying to use AI as well, and try to use the large data and find the best route using heuristic. So I actually follow them and find out it works most of the time. But of course, there was a joke that there's a guy put 50 mobile phone in the back of his car. So it will try to create a red signal, and so direct everybody away from wherever he's going. So that might be something that we can work around the system. And also using this new technology, we have to be careful that it's not just all interlock. It could be programming error and the logic failure. And sometimes the programmer may not be working the railways. They may use the different terms. And when we worked in China before, we find out that some of the Chinese terms are very different from what we use in Hong Kong, although we both use Chinese. And that may create problems once you look at the operating modes as well. But then when we look back, this main machine problem are not old, and it has always been one of the dominating risk factors, contributors, even in nuclear power plant, aerospace industry. The one I'm showing here, although it's a bit small, it is from World War II, when the flap and the gear are kind of like putting side by side, and they do look very much alike. And if you look at the two of them, it's just two switch. And it end up during panic time or when the pilot was shot several times, and he might flip the wrong switch, lower the gear before lower the flap, or lower the flap before lower the gear. So as time goes on, they all learn from that and try to use a square and a triangular different shape to do that. But you look at a new aircraft, this is an F-22, you can't even see what switch it is because it's all in the touch screen. So you got to have thousands of hours of training before you can get into using it. So when you look at driving cab design, I think the industry had gone through something similar, from having one of these as a driving cab. And when you look at it, it's a locomotive and there's tons of things in it. Hopefully you can enlarge your figure and to see what it is. And to a much more elegant way of design, going through a lot of ergonomic analysis to make sure that the driver typical height, typical weight will look at a certain angle. And that has gone through years of studies, and we still have many lessons to learn. Other areas, like for example, oh, I skipped this one. That is a Hong Kong taxi driver. Some of the Hong Kong taxi driver will look at 10 different mobile phones at the same time, because the law says, I think they can have up to 13 devices in front of them. So they've been taking calls everywhere they go, and hopefully they can have a better user interface. Signal sighting has always been a problem. There are several accidents like that before. It's all due to human reading the wrong signal and machine, even OCC layout. And we have similar things like that. Any example from your side, Eric?
Oh yes, I think these are a classic example. I still remember one incident where a driving cab is already adopted a very modern design, ergonomic. The one actually quite look like the one picture you showed, but there are two buttons there look very similar, like the flight control you mentioned. It's the emergency stop. This kind of emergency stop used to be look like a push button, right? A mushroom shape, and they use the same for an emergency pantograph down button as well. So the two looks really similar. And we have an incident where a train has reported have smoldering on the roof of the train. And so according to the procedure, the best way is that the drivers to drive the train to the platform and detrain the passenger. And you never stop the train in between nowhere. So because then the fire brigade cannot come to help you. But in this particular incident, under a panic situation, the driver just hit a push button and it hit the pantograph drop button and the train stopped it in the middle of nowhere. So it is a very typical design issue that you don't use two similar buttons for different objectives, but still we commit the same error.
Yeah, that was 2006, wasn't it?
Yes, Valentine's Day.
And yeah, remember that particular incident. I was there right away, and the train captain has just accidentally lowered the pantograph and then use up all the batteries, so he can't even raise the pantograph again. And that also contributed to a lot of problems, and with evacuation inside the tunnel. And while the train could have safely go into the station, which is only 500 meters away. And so that hopefully, well, luckily nobody get injured at all, because it was a rather modern railway and with a raised walkway. So, and at that time with side evacuation, so everybody can run out in a safe manner. And also, fortunately, at that time, not too many people having mobile phone. So not too many people try to stand and take photo or selfie in front of the train and the fire. But that has changed. If I remember well, back a few years ago, when we have an arson case in one of the stations, at least 10, 15 people are sticking around and just take selfie, and they want to be reporter right away. And that is actually creating hazards to everybody, because we have to send station staff to babysit them, and that take away the manpower who could have been helping other passengers if needed. Yeah, so we try to summarize all these risk technology. Let's see if I can shut down this hold it on the whole. It's hard to control the screen at the same time. And we try to summarize most of this risk item that maybe every participant can append to this list. That if we use the technology in warning mode only, should it be fail-safe? That means if it doesn't get any input, or the system itself feels that it's not healthy enough, would it give a warning, or would it just fail quiet, shut itself down? And what is the safety integrity level SIL required? And Alex mentioned the other one was SIL2 for the light rail system. But once you get more active into controlling the train, will it become SIL4? And how should we look at this? If you have the degraded mode, with the system smart enough to, hey, I'm sick now, operator, please take over, and I will stop giving a warning. And would that be something that in the future? This is quite of an interesting argument that which way it should go. Alex, what do you think?
Oh, yes. Well, the argument still goes on, as you rightly mentioned, this light rail system that we put on. Now in the warning mode, everyone feel quite comfortable about this, because the driver has to drive the train anyway. And so with or without a warning, it's not a big deal. But then once you start interventing the brake or other things, then you run into other risks, that if the driver now become over-reliant on the system, then a fail not safe occurrence will result in a tragedy. So well, there is still a lot of debate with the regulator, with other experts about this, and to be honest, for that kind of system, it is difficult to confirm it is SIL4, because some of the ports are not designed as that for that purpose.
Yeah, I'm driving a car. There's a warning on the side view mirror. If I try to change lane, and if they detect there's a car on the adjacent lane, the light will flash. So once I depend too much on it, I will start turning my head to look, which is not quite safe to do that. So then I just end up shutting down the system, because I don't feel safe to rely on the warning light, just in case it skipped the car, then I will have to run into the other car. And we also run into the risk of letting technology take over that's beyond warning, like auto driver. And like Alex, you said that FAO is quite common now in people mover, and even single line direction train. And we have an operation in Sydney that run fully FAO, and operation in Hong Kong, the Island Line. But once you go to auto driving and auto braking will be ATP will be easy. That might be the time that we can start showing this automated driving problems. And if you see that, you look at the car and then you run into it, and somehow there is still some glitches in allowing car to do that. Railway might be easier, because we still rely on the ATP backbone. So once we have someone occupying a block, regardless micro block, moving block, then the train behind it, based on the train braking profile, will not be able to get into my block. So I'm still being safe to do that. And so a lot of this automation got to rely on ATP and other systems, and rather than just put down automation. And people think that once we go FAO, we can get rid of everybody, and which is quite not true. We find out that once you put in FAO, you actually have to hire more people at the station, and also on the train as well. So let me stop this Tesla compilation of problems, and you can Google it and find it on YouTube. And it's not just Tesla. I think most of the automation, the technology is still not mature yet. So especially in rainy days, and there was one car that was looking at a truck, and with a green background, green painting on a truck body. So you think it's just a background, and then you ran right into it. So there's a lot of automation programming need to look into. So that get into our third bullet is the risk of programming error. If there's a programming error, who is going to be responsible and who is going to find out there's a programming error? Especially now the programming is in Python or in different languages that we don't even know how to do that. Do you allow human intervention degraded mode? And do you actually know it's degraded mode? Like our example showing GPS. Do we think it's an error, or do we don't trust the system and we take over rather than follow the system? Sometimes AI may give you display issues, language issues, and you may look at it or listen to Siri, can you buy me a cake? And Siri think he want to kick me and just kick my behind. So data overload, there has always been a problem that once you have a lot of warning system, you end up with shutting it down. And I think we have a lot of these warning and false alarm issues before, the same as TPWS, AWS. This can go on. Alex, what do you think? Do you have any other example we can share with everybody here?
Okay, yeah, well, there are a lot of it, but programming errors is really a very challenging thing. I talk about a SafeTrack app that we use, which is supposed to allow to make sure that our staff get an authorization before they enter the track area. But during the early introduction, we found quite a number of program error because the programmer is not a railway worker, and therefore sometimes the kind of people usage he couldn't expect, and therefore the problem is it is difficult to find out which line of program has an error and how you can improve it. So you really need to have a strong team of people to manage this kind of introduction, rather than just relying on a contractor somewhere in Zhuhai to help you to do that.
Right, but by no means we're not trying to stop this. I think we all want to embrace the new technology. We just make sure that they are really not showstopper. We just need to properly manage the change, and using new technologies also change. In the upper right corner, you will see one of the FAO incident on the Japanese Yokohama line. Alex, you have the one page on this as well, right?
Yes. I think they have a wrong connection. Some here that the train moved somehow the other way around, the other direction. Yeah, and clearly they didn't anticipate that. Yeah.
Yeah, and that line has been running since 1989, and you ran the wrong direction and went to buffer stop. And also, luckily, no serious injury from that one. But it's very hard to detect with an aging cable problems. But I think all this is going back to change management. If we can risk manage the change, then we should be able to apply new technology. We just want to make sure that any change management assessment got to be done by all phases, not just to the big bang at the end. So for example, if you look at this circle, you'll find this typical step that I think all these new technology must have to go through this, is identify all the hazards, all the risk of changes before we put it in. And that changes could therefore several different places. And I think we should emphasize on human error, human factors, and different issues and man-machine interface, and also on the recovery contingency plan. And during the hazard identification stage, which is pretty much the most important stage, we should always involve the users, the train drivers, because like Alex said, the programmer, they just program it. They may be PhD, but they don't know the jargon. They don't know the way the train driver will react. Once we go through this plan, do, check, act, evaluate, assess the risk, and mitigate and control it, and then communicate it, and then we just have to risk manage it. If you look at identification, and we can actually employ typical tools, although there's a lot of software issue in there, like HAZOP. And in the HAZOP, we can use guide words such as, what if this goes high, what if this goes low, what if you get false alarm, and how the people react. and also a lovely tool, bow tie. I think bow tie would be very useful here to find out what stoppers and what are the stopping point, what are the hazards, and how do we escalate it or de-escalate it. And once we have an incident, how are we going to recover it? And if it's FAO, then how do we take over the line? And will there be any fail-safe? Luckily, train can fail-safe is to break it, and rather than airplane. And go on and on and on. We just want to make sure that most importantly is you must involve the users and all the stakeholders, and then go through this plan to check cycle to see how it works. And we also importantly to communicate to everybody and training, user feedback, and that has to bring forward rather than going towards the late phase. And I think using new technology, when we learn from the past, is that the training has to go much earlier than before. And even the cutout plan, implementation, commissioning, there's a lot of problem during live commissioning, in situ commissioning. So we want to make sure that unless you're a brand new line, if you're introducing new technology on the existing line, make sure that the cutout plan and whether you're running virtual or hybrid mode, and every one of these have to have proper approval. And after all, you must have a good process management plan sitting in the back to make sure nothing will go wrong. And just in case something goes wrong, your business can recover. What do we have, for example, is sharing, Alex, over here?
Oh, yes. I think this typical poses is this pose is quite typical for introduction of technologies, and in our cases we start again from the user requirements, start from all these design features, and go for example, for this ISPS, I mean the light rail system that we talk about, we possibly go through all sorts of hard stops and bow tie and what if analysis as well. But more importantly, I would like to mention here that the time you spend on testing and commissioning is really important. And you may need to find some crazy guys who has this ability to break in your system and do all sorts of crazy things, then to give us the assurance that the system is really working. And also a lot of good technologies, like you do not turn it on, but just do some background monitoring and see what happens, can also help. In MTR, we have again, Vincent, you don't know this, another committee to look into this, and we have processes like this this vote you mentioned here, to make sure that every step is has gone through before you approve a technology. But on the other hand, someone will always say that, hey, it's now the new era, and you have to speed up, otherwise the technology is now become old when you introduce it. So it's a balance there as well.
Yeah, we have to put in the 3-9 defense. But once you put it that way, there's another step that we must do is cybersecurity, because now we're relying too much on new technology, which mostly are Wi-Fi based and using wireless network. So you can have someone try to hack in, and that may not be a good idea to open the network for someone to hack into the network. So that brings us to the closure and towards the end of the hour. Wait, not yet. Oh, we have to go back to share screen with the one more page.
Okay, I'll do it. No, don't worry. You see, technology is the problem.
Yeah.
Is it on?
Yep. One more page up. Can you go up one page?
Okay. One page.
Yep. Let's just stay over here. That's another technology issues. That if you click too much and there's a delay. To wrap up, I think this is Alice and I joining this page to figure out that certain technology are accepted, and such as there's some health monitoring, diagnostic, warning alarm, and Alex showed some guided robots, and automation of mundane tasks, and except the FAO and, well, not FTO, there's a typo there, And you have seen most of the people move in airports and single line direction. We kind of trust that already, because at the worst case, you just break the train. Even metro operation, and in our Sydney Island South line, and we're going to have more and more FAO, but those are mainly on single line. I think ultimately, being a railway engineer, and we really want to see, not really want to see, but I think ultimately there will be a fully automated complex network. But then if you look at spiderweb network like London or Tokyo, and it's like, don't know how many years we have to wait until everything is fully automated. Another dream that we have, it could be a fully automated maintenance for line 1, line 2, line 3. What else in the wish list, Alex? If we can have this AI intelligent safety to run the railway.
Well, I think it's countless, but of course, we might want to help our passengers more, and therefore we are having more and more intelligent way of letting the passengers to behave safely, predict their behavior, and also intervening when necessary.
Yeah, that will go back to our last page. I lost control. Yeah, so I think we just need to embrace it. Like Alex put it before, this is not a silver bullet, but we just need to make sure that everything is risk managed, and technology is just like a double-edged sword. It will help us if we use it wisely, and it may create more problems if we do not have a good program and system to systematically push it out to the line to make sure frontline staff, trained driver, and operator, everybody know what to do. So that will be the end. Anything to wrap up, Alex, from your end?
Well, a very good summary, Vincent, and I think it's time we open up the floor to Q&A, right?
Yes. Let's pass back to the host, Edward.
Okay, yeah, thank you very much. And I think that really highlights the benefit of having a safety managed by an engineer. I think I've got with the noise. Can you hear me?
Yeah, I can hear you.
Yeah.
Do you have the echo problem?
Yes.
Okay. I think I won't carry on with too long if this is the problem with the vibration. The echo. But the benefits of having a safety manager managed by an engineer, and the combination, we can really see the advantages in those. And I think even at the very beginning, I could see the links with yesterday's presentation, and it would be interesting to see if we are linking up with the international perspectives of what's going on, to see if we can learn lessons. For example, with the technology for track access, which we covered yesterday. What I also found interesting is about the data overload. I was at the RAIB Accident Investigation Conference last week, and there was a really interesting thing about safe work packs, where these packs were so big and so wieldy that they weren't really that safe at all. So they managed to put them onto an iPad and read, but as Alan Spence pointed out, having 1,000 pages on an iPad wasn't the best use of the technology of overloading the information. And I also think, where you covered cybersecurity, which Dr. Emma Taylor, who did a presentation for us a few months ago, will be covering some of these aspects tomorrow about when the intelligent safety can fail. Emma might be trying to stop people getting into the technology, whereas we're looking at getting in to find out if it works. So if we do have any questions, David?
We haven't, but I have one of my own, if I can ask it. A very, very good overview of the benefits and challenges of IT, AI, etc. Excellent. Thank you so much, Alex and Vincent. Just one thought. Have we got a emerging view as to the demonstrable benefits of the introduction of these AI and IT elements? I'm thinking in terms of, you may be in a very sort of modernish systems rather than what we have in Europe. And I just wondered, of all the various applications. Is there any sort of emerging view as to how much you can squeeze out of the use of IT in terms of reduction of hazard risk, and can it be demonstrated? I'm just trying to think about, you know, to convince others of investment in this area.
Yeah, good point, David. Well, actually, you're right that in Hong Kong, our asset is relatively newer, and usually it also depends on the passion of your leader, that whether he really wants to try all these new things, while the old traditional methods still look very good. But from our experience, what you find is use of AI or technology in preventing human error is sometimes very good, and it's not expensive. All this video analytics, etc., they are already there. And for example, Vincent mentioned about signal sighting, and I've been chairing the signal sighting committee for over 10 years already. It's something that you can never solve, because you always have geometric problems, you always have a speed, whatever, sun, background light, etc. And in particular in UK, you have some complex junctions where I find your driver is just amazing. They can see all the signals. But now we are actually using video analytics to help the drivers to look at signals, and actually they can look faster. And you can actually set sensors just in front of your signal, and then the sensor can send a radio signal to your driving cam to tell you what is showing before. So these are not very expensive things. Think about nowadays, you got all 7-Eleven shops, convenience stores, their CCTV are already all AI enabled. So it's not really difficult, but as a warning, it is good. But if you really want to automate tasks, get rid of people, getting more time or whatever, then I would suggest you think twice, because it's not that perfect solution. Now, Vincent talked about Tesla, and I think I would like to have a Tesla, but I wouldn't turn on the automation mode. Vincent, would you?
Many cars, even Infiniti, Ford, they all have semi-automation. I'm driving a Subaru, and what it helps is if I don't stop fast enough, it's almost like a semi-ATP. It will break for me. But then if I rely on it totally, then I definitely will crash. So I think so far we use AI on little things, like Alex mentioned, detection of this and that. And the question there is, has MTR looked at technology to reduce the risk of platform train interface?
Right.
IoT is easy. We have technologies that even in construction site area to detect where the peoples are. So it's easy to adopt a camera, several camera, to mark all the people and to see how it goes. But like David points out, that Hong Kong run a rather modern railway. We have platform screen door in most of the lines. So it's not very helpful to use that technology, except like Alex mentioned, the user interface, like the passenger information system. And right now, we can even tell people that which car of the incoming train is more empty, that people can divert away from the packed car and go to maybe the front, the back, or whatever, class number 5. And that will be quite a good investment, because you get a more satisfied customer and who can stand into a less crowded car during peak hours or non-peak hours. And if we have a platform that doesn't have platform screen door or platform gate, that maybe we can have AI to mark the people. If they get too close to a platform edge, then they will give a warning. However, once you give a warning, then the person has to come back. And in some of our overseas operating areas that we have a lot of people falling over, not a lot, maybe a few cases every year, usually happen at 5 a.m. in the morning. So these can actually help the operators when there's not enough manpower on the platform to check whether the person is walking towards the platform willingly or staggeringly or being drunk. So that will be kind of operation AI. I don't think we have put in that technology in full phase, but we definitely are trying some of those.
Yeah, Vincent, I think you're right. Using AI given warning sort of thing if someone is really sick or it's difficult to use a warning to stop it. But that brings up the idea of you mentioned bow tie, right? If you can't prevent them, you can minimize the consequence. And you probably understand that in some of our platform, we still have platform gets like 300 millimeter wide. And so what we did was we put what we call passenger mat on the track. Well, we can't stop people falling there, but the risk is when you start running a train with someone there, then you kill them. So the passenger mat is really a great thing. It's cheap, simple. Put it there. Someone drop there. It interlocks with a signal. The train can't move, and your station staff got to go there, check whether something happened. Well, sometimes we have a bird, or sometimes we have a cat, but they save a lot of life as well. So it's not too difficult. But we are also looking into AI or other things to do warning. But so far, I found the other end of the bow tie is really helpful.
Right.
Hong Kong, we have our own problem is if you use too much AI, which include cameras, and the people here, they don't like cameras. They want data piracy. So in some of the line in China, and we actually use camera and to detect people going through the gate, sort of like knowing which gate has more people whatsoever. And that camera has facial recognition capability. And one of the lines that we operate in China claim that they have arrested over 700 people over the year. Those are most wanted criminals through the facial recognition. So that's one of the added byproduct of the advantages using AI technology.
Yes, demonstrating the social benefit.
Yeah.
Okay, I think we've answered my question and Andy Carney's question. I've got no others here, Ed.
Okay. No, I think you answered lots of the questions because it was more thought-provoking than one needing answers in most cases. But I think, Alex, I think it'd be really helpful if we can get a connection with Nick Millington on some of the track safety issues that you discussed. I think they'd find them really, really helpful. And Vincent, first of all, thank you for getting up at this early time in the morning. I guess it's now 3:08, and you've got not long to go before you start work on the day. And thank you once again for your very informative and candid views of information technology. And like I said, cybersecurity will be covered by Dr. Emma Taylor tomorrow, which will link very nicely into what you've spoken. But if I could just thank both yourself and Alex for an excellent presentation. And Alex, I look forward to seeing you on our committee quite soon. Vincent, thank you very much.
You're welcome. Thank you. Bye-bye.
Bye-bye.